Okay, and we are recording. You can please talk to us about Fargate and Lotus. You can take it away, please.
Cool, awesome. So, hello everyone. My name is Liza, and I work at aleios as a serverless software development company, and yeah, serverless developer there. And yeah, today I'm just going to talk to you about Fargate tasks and running load tests, basically how we implemented load tests using Fargate tasks. And yeah, hopefully you guys can learn something from it. So let's start with the very basics. What is ECS and Fargate, and how does it all work together? So ECS is essentially AWS's version of Kubernetes. So it's a fully managed orchestration service, and it just allows you to run containers, and helps you run them at scale. So you can run your containers either with ECS or Fargate. ECS, I think most people will be quite familiar with if you know AWS. It's basically allows you more control over your infrastructure, because you're busy setting up the container yourself. And that means that you then have to also handle your scaling, patching, instance management, those sorts of things. And then you can run it on Fargate, which is the serverless version. And basically, it just says that AWS is going to manage that service. So they manage the infrastructure and things like scaling. And then you really only just have to focus on application deployment. So it's a really nice serverless use case. Cool. So let's have a look at some key concepts with ECS. I know this is a bit of a boring slide with lots of definitions, but we'll go through it because they are relatively important to know. So container, everyone knows containers, I think. It's essentially a standalone package of software with your code, runtime, libraries, those sorts of things that you can run an application. So these are like Docker containers. Then in ECS, we have things called task definition, and this essentially describes your application. So it'll say the number of containers that you want to run, the images that you want to use, and the sort of CPU and memory limits, networking, environment variables. It essentially just defines your application as a whole. Then we get things called tasks, which quite easily to understand is just an instantiation of a task definition. So basically just runs the containers as per the definition, which is quite nice. And then we have something called services. So a service essentially manages the deployment and scaling of tasks. So your task sort of lives within a service. And basically the service is really nice because it ensures that you have a defined number of tasks running. If you said we always need to have 3 running, it'll make sure that you always have 3 running, and you can also set up scaling rules that to meet the demand. So if you've got your application getting really busy, then you can use the service will automatically scale up, which is really useful. And then cluster is essentially just a logical grouping of your resources. So it's essentially just the environment where all of these tasks and services are running. Cool. So away from all the words, let's see some pictures. So we've got the task definition, defines all our things, defines our application, and that along with a service, which basically manages your tasks and how they run. And then this all lives within a cluster. Cool. So that should make a little bit of sense. Now we have a little bit of background before we dive into the actual project that we're working on. Cool. So at our company, we had a bit of a problem where we weren't doing load tests enough. And when we were doing load tests, it was really complicated, and it was a really high barrier to entry to get to using the tools, figuring out which tool is the right tool to use, all those sorts of things. So we wanted to build a tool that would make it nice and easy for people to use. So you can run quick and easy load tests. And also the most important bit, I think, is to get out some really useful performance metrics, because sometimes the things you get out of load tests are hard to understand. You don't really know what's going on. So we did a little bit of research, talked around with some of the people in the company, and decided to use Artillery as the base tool. So Artillery is a command line load testing tool. And we decided to use this as like the base to kick off our load tests. And then the idea is to build an infrastructure around it so that it's easy to use and that it provides good usable results for each test that we do. Cool. So this was the very initial architecture that we decided on. We'd have a client sends a request to API gateway, which would trigger an SNS topic, and then that would trigger a Lambda. And the Lambda would use the details in the load test request and send them through to artillery and run that. The results would be stored in DynamoDB, and then we'd send an email notification letting the client know once the test is finished running. So that's all good and well, but there were obviously some problems with that. So the first one is artillery is a command line tool, and we need it to be installed as a layer so we can use it via the exec or spawn sync command. So we had to add it to the Lambda layer that we were busy using. But then the problem comes in is that artillery is a really big package. It's about 360 megabytes. And Lambda layer is restricted to 250 megabytes. So we couldn't do that, and that didn't work. And then the biggest problem of all is that Lambda only runs for 15 minutes at a maximum. And if you're wanting to run some more in-depth load tests over a long period of time, you really need a tool that can go for longer than 15 minutes, because you might want to run your load test over an hour or 2 hours or even more. So those are the problems we faced. Just a small note on the package sizes. If we were going to continue using Lambda, we could have instantiated our Lambda with a Docker file, because that does allow you to have bigger package sizes, basically up to 10 gigabytes. But because the runtime was a problem for us, we decided not to go with this. So the solution, we decided to use Fargate tasks, big surprise, to run our tests. Reason being, Fargate doesn't have any restrictions on runtime. It doesn't have any package size issues. And also we could use the serverless nature to stick with Lambda, keep everything serverless of Fargate to create our own longer running Lambdas. So this is the final architecture that we came across. It's slightly more complicated, and there are some extra details here that are not necessarily that important. But what we decided to do, we're still hitting an API gateway. And then instead of SNS, we decided to use a step function. This is mostly because we wanted to do some orchestration between storing state in DynamoDB, of like when your test is busy running, when it's completed, and also doing things like sending an email after the Fargate task is finished running. Step function also has a really good integration with Fargate tasks, so running them is really nice. And the biggest thing is that for our Fargate task, we wanted it to be as serverless as possible. So we had our Fargate task scaled down to 0. And the step function allows you to instantiate a Fargate task from scratch. So it basically spins up the container, spins up everything. And then once execution completes, that all spins down again. So you're not paying for idle runtime, which is really nice. Cool. And then we just in our company internal tool wrapped it all in a nice retool, low code platform, just to make it easy to use and see those nice results. Okay, so now everyone knows what we're trying to do, sort of what our plan is. And we're just going to dig into the details of how we actually did this and how all those integrations work. So we're going to be looking at some code. This is the stack that we basically created. In this whole project, we used CDK, which is a really nice tool that AWS provides. If you haven't heard of it, I'd definitely give it a try. It's really nice. It's essentially Terraform, but you can do it in code and it's more readable. So yeah, really enjoy that. Cool. So as you can see, we are basically just defining all the different components in AWS that we spoke about just now. So we have our table, we have a bucket, we have our Fargate task, which links to the DynamoDB table, and we have our step function, which links to the Fargate task and the cluster. And then we have our REST API. So as you can see from here, all of this is getting imported from a package. So this package is actually on NPM as well. So if you want to go have a look around on the code or just, yeah, have a look in general, it'll be quite nice to be able to do that. Cool. So let's get into the details of the Fargate task component that we're building. So this is just a little code snippet. So the biggest thing is our VPC. So to create a Fargate task, we need to create a VPC that hosts our cluster. So you can just ignore the max AZs. That was mostly just a cost saving thing. So we've defined our cluster, and then we define some roles and create our Fargate definition here with some execution roles just to make sure it can execute what it needs to do. And then we add a container to this task definition. So this container is going to be defining basically most of our application code and what this task is going to be doing. So you can see here that we get it from an asset, and I'll show you that Docker file in a second. Then also something that I want to talk about is just because Fargate is not quite as integrated as Lambdas, you need to do a little bit of extra work getting things like DynamoDB integrated. So we need to create a gateway in our VPC that allows us to talk to DynamoDB tables, and then add some permissions for that. And then also make sure that, and I think this is pretty normal, our DynamoDB gives the task definition, execution role, some write data, and same thing with the bucket. Cool. So let's have a look at the Docker file. So a lot of this, the most important line is just the command line, which is essentially we spin up our container, do some basics to get it ready, and then our command just goes to the next.js file that we've created, and that is essentially our application code, and that's going to run. And how this command also works is it will run that index.js file, and once that execution stops, the container will be spun down. So that whole scale to zero thing we got going. Cool. So just a quick look at the index.js file. This is the code that actually runs it. As you can see, it's quite basic because it's more like a wrapper with all our helpers that are inside. Basically, we run our load tests, and then we save some output to S3. So this is the actual running the load test logic that I'm going to talk to you about. So first of all, we've got this config.json, which we get from an environment variable. And I will speak about that a little bit later. But that environment variable comes when we instantiate the container via a step function. So that essentially allows us to take the details that come from the request from the client and propagate that through into our actual container once it gets spun up. So we get our config, do little basics, do some status updates for our table. And then this is how we actually run the test. So as you can see, we're using spawn sync. And this essentially, this first command runs artillery and produces some output. And this is what actually runs our test. And then the second command actually is artillery command that actually generates an HTML report. If you've ever worked with artillery, it actually is quite an interesting report. It does give you some details. It's somewhat readable, but we wanted to improve on this and make it a little bit our own. So yeah, and then just a very good tidbit, something that causes lots of headaches is the standard IO inherit thing with spawn sync means that the logs of the command you're actually running actually show up in Fargate. We had a lot of problems trying to figure that out. But yeah, so that's definitely a useful little tip. Cool. So now we've defined our Fargate task and we know what that looks like. Then the step function is where it all sort of starts, and that does the execution and all those sorts of things. And for the most part, we use this run task step, which integrates directly with Fargate, which is really nice. And as you can see here, just a basic overview, we add the execution to DynamoDB just for the status. Then we run the actual task. Once that's completed, we update the status to test completed. And then in our request, we have an optional email input. If you do put in your email, then it will send you an email once the tests are completed, just because if your test is running for an hour or 40 minutes or 3 hours, you don't have to keep checking when it's ready. You'll get a notification. And then, yeah, either sends an email or doesn't send an email. Cool. So the biggest thing is we have API gateway, and then we have our step function. How do they actually communicate? And this was quite an interesting integration that I found while we were busy doing this, is that you can just integrate them directly with each other. So I'm not going to go into too much depth for this, but essentially you can create this request template, which allows you to define your input, and it allows you to get that from the request that you've sent. And you can see it adds it to this model and then gets it from that resource and adds a method to that, which just means that you can directly integrate your API gateway to your step function. You don't need like a Lambda in the middle trying to trigger the things, which was really interesting. Cool. So now I get to the actual step function. So the way that we implemented this was quite logical. So initially, we just defined each of our different steps and what they're going to look like. So, for example, we have our add execution to DynamoDB. We define that in a separate function that I'm just going to show you in a second. And then we say a similar thing, have our run Fargate step, our update step, and our email step, those sorts of things. Cool. So the DynamoDB step is not super important, but it just gives you a little bit of an overall view of what these things are like and how they work. So this is essentially what the DynamoDB put item looks like. And you basically define your table, you define your item, and you can derive some input from the step. So, for example, you get this .input, and that is a direct integration with the step function that gets the input, which we've defined as the request sent by the user. So this will be our config. And then just an interesting thing here, you have this result path option. And we've decided to discard it. So with a step function, you get some data into your step function, and depending on your step, you can either take that data, transform it, and then output a different data. In this case, we didn't want to transform anything. We just wanted that data to pass right through to the next step. So that's why I use this discard function. Cool. So that's our DynamoDB step. Now we look at our Fargate step. So it's pretty self-explanatory. So we have our sort of integration pattern. It's just running the job. And then you link our cluster and our task definition. And then we define these container overrides, which are relatively important. So essentially defining our container from our task definition. And we also set some environment variables. You know, earlier I mentioned that we pass in our environment variable to the container. This is how we do it. So we define the name, and then the value is pulled from this $.input thing that is part of step functions functionality. And we basically get that value and set that. And then we also set things like table name, execution ID, bucket name, those sorts of things. Cool. Then we've defined now all our steps. I'm not going to go through all the other ones because they're not that interesting and not that important. But then this is now creating the actual flow in the step function. It's quite a cool way of doing it. You essentially just create a chain. So we have this add execution to DynamoDB, and then you say .next, run Fargate step. Then you have your Fargate step, .next, update the status after the test. And this is quite interesting, and you can do a lot of interesting things with it. And it's just quite a nice way of defining this. And you can also add cut clauses. So if anything fails, then do X, or you have this this check input choice. You can have .when statements and otherwise statements. So if you have an email, then send it. If you don't have an email, don't send. It just was quite a nice way of defining that. So now when you actually get to, you've defined all the things, now you actually instantiate your state machine. You basically instantiate by defining this definition body, and you do it from a chainable. So essentially what you do, you just put in the first step, and because that's part of a chain, it knows the execution that you've just defined, which is really interesting. That's how you basically define that. And then obviously some permissions, which are always important. Cool. So now you know how the whole thing works and what it all looks like. So I'm going to do a little demo. This is just, as I said, an internal tool at the moment, and it's just going to be very basic. So this is essentially our front end that we built with Retool, which just allows you to work with artillery in a slightly easier way. So we have our config page here. So we have links to artillery. So you're essentially just writing artillery code. And instead of YAML, you're just writing in JSON, which I think is better because YAML is really hard to understand.
Hey, Lisa, can you zoom a little bit more?
Yeah, for sure. How's that? Cool. So I'm not going to go into too much depth for what the actual config for the artillery tests are because it's just completely artillery. But you essentially have a target. Right now, I'm just going to use artillery because it's easy. And you can have some plugins and you have thresholds and you can have different phases where you can define durations and what the arrival, what it needs to ramp up to, those sorts of things. And you can have some thresholds. So your P99 needs to be 100. And if it breaks that, then you'll get reports on those sorts of things, which is just really interesting. Then we have this where we can name our tests, which is just really useful for developers when they're busy using it. Got that going. And then, like I said here, we have the option to send ourselves an email, which is really nice. And then you can say run load test. I've also got small bits of frequently used features, just some internal helping with, like, if your API has authorization. This is really just minimal. And then once you've run your test, you can go to the test results page. Which then you can see we have a couple of tests here. Some is completed, some has failed. And as you can see here, this is our test. And we can see that it's been initiated. So this is when our step function has started. And I think if we give it a little refresh now, in a little bit, it will tell us that the test has started running. So this is sort of what that will look like. You also have access to your config. So this is the config that you ran the test with, just so that, you know, if you're a dev and you're busy using something, you can go back and look, okay, what was this test run with? What was the performance that we were trying to test against? And then if I just have a look at one of these tests, we have, at the moment, a very basic load test result. We still need to add a little bit to it, but this is basically just given a nice infrastructure. Tells us the test duration, the response time, average response time, P95 response time, and the number of successful responses versus unsuccessful responses. Obviously, this has gone pretty well. And then we also have this table, which just shows us things like our failure rate, our response time, request rate, the virtual users, how many people that were using the platform or using the endpoint. And basically just gives you some details on how it actually performed. And then, yeah, I think if we refresh this, yeah, you'll see the test is running. And in a little bit, we'll get an email at some point telling us that our test has finished running. But, cool. So let me continue. The downsides. So I'm not going to tell you that Fargate is the perfect tool and you must use it for everything because it's just great, because that's just not true. You always have to really think about the application of what you're using Fargate for and if it's actually useful. So the biggest problems that we had is logging. Logging is not that great, especially when you compare it to Lambda. So it just sometimes makes things slightly more difficult to figure out where things are going wrong. So debugging is a little bit more difficult. And then because of the way that we implemented it by having a Fargate task living just, and then the container spinning down every time and spinning up every time you want to use it, that means we have quite high cold start times, like a minute or two. And this is obviously not ideal if you want to do short running things. So like a Lambda, this would be completely unacceptable. But because you're running long-running tasks, so if you're running a load test that runs for an hour, that 1 minute is not really going to make a difference. So it is negligible if you're using it for the right purposes. And the other option that you can also do is you can have a container running constantly, so you don't have one that spins down every time. That's just not how we did it, because we didn't make use of any services. We just used the tasks straight. And the spinning down obviously adds that cold start time. So if you just have one that's constantly running, obviously it will cost a little bit more, but it means that you don't run into that problem. And then also there's a little bit of extra setup when you want to integrate with some AWS services, like I said, with the DynamoDB having to integrate with that endpoint. So yeah, those are just some things to consider when you're looking at Fargate. And then because it is a useful tool, but for not necessarily everything, these are just a couple of other applications that Fargate could do quite well in. So things like image and video processing. Note that Fargate doesn't integrate with GPU capacity, so like your very intense image and video probably won't be ideal. But if you want to do some basics that maybe take a little bit longer time, this will definitely work. And then also large data processing and very heavy computational workloads. So if you've got things like ML models that you want to run in the cloud and you don't need it all the time, you just even need it now and then, and it runs for a couple of hours, then this is a really good way of actually using that and leveraging the serverless nature of Fargate and still getting your performance out of it. So yeah, I think it is just a really interesting application, and is just something I really enjoyed and learned a lot from. So yeah, does anyone have any questions on that?
Thank you very much for your presentation. It was
Cool.
nice to see how you guys used artillery.
Yeah, interesting.
So before the questions, there's a link in the chat. You can complete the survey, and that will be your entry to win some AWS credits for you to use. We'll do the lucky draw after the questions. So yes, if there's any questions, you can just unmute yourself and ask them, or paste them into the chat and I'll ask them. While we wait for some people, I have 2 questions. So the artillery NPM package is not that big. Why did you use a CLI, or why was the CLI used?
What do you mean? Why is it such a big package?
Yes, because if I look at NPM, it's just like a few megabytes big.
I mean, we did implement this about at the start of the year, so something might have changed. When we were looking at it, artillery was quite big. It was just the CLI that we were trying to use.
Because there's an NPM package that you can install directly, so it might open up a few use cases where you can just use that instead.
Yes, so I do remember that. We worked with that, and for some reason we couldn't get it to work with Lambda. There were some, I can't remember the exact details, but we're having some issues trying to get it to actually run the tests in the Lambda with the NPM package, which is why we went for the CLI tool and just not the NPM one.
Okay.
Yeah, if I remember, I will definitely send you the details of why that happened. It's just not in my brain right now.
Okay. Any other questions?
Hey, I've got one if you guys can hear me.
Yeah, we can hear you.
I may have missed it, but how did you say you were handling logging? Because to my knowledge, if it's just running in Fargate and it's a container, how do you even connect to the container to see the logs?
So we did, my memory might be slightly foggy here. I'm just going to get to the right bit. So when we added the container, you can add some logging here. So there's an AWS log driver that you can add, which will allow you to see those logs. And then also because you are running command line arguments using SpawnSync, we use the standard.io inherit option, which basically makes sure that all of that output gets logged to the container logs that we've set up.
And then those logs will go to CloudWatch, correct?
Yes, I'm pretty sure. Yeah, it's a CloudWatch integration.
Okay.
Oh, thanks a lot.
That's a pleasure.
How long did it take to complete this solution?
I think we're working on it for about a month. The initial phases when we started with initially just the Lambda was a lot of R&D, busy trying to figure things out. And then it was a team of 2, and we worked on the actual fully fledged solutions. We definitely had lots of issues trying to figure out what Fargate is. Before this, none of us had worked with Fargate before or even really knew how to work with it. And we didn't have anyone in the company who worked with it either. So it was a lot of discovery and a lot of learnings, and yeah. But it was a really interesting process. So I really did enjoy it.
Okay. And you're using Retool as a front end for this? How does that work?
Yeah, so Retool is quite interesting, and I can even potentially show. So it's a low-code platform, which is essentially just drag and drop front end, which is really interesting and works quite well. So you can just go and edit your app, and you can quite easily add things like a table or buttons. You literally just drag it in.
Wow.
Yeah, it is. It's really nice for small scale things, something like admin dashboards, this sort of stuff, like internal tooling. It just means that you don't have to spin up in a whole entire front end. And yeah, it's probably not the best tool to use if you're building out like a huge project with lots of different screens and many different users. But it is a really cool tool that just makes, front end dev a little bit less of a hassle.
Okay.
Yeah.
Do we have any more questions? Going once, going twice. Okay, I think that's it. And it does not look like anyone filled in the survey, which means no AWS credits. Sorry, but that's how it works. If I don't have your email, I don't know where to send it. I'll maybe give some credits to Liza for a great presentation. Yeah, I think that's it, everyone. I'm going to stop the recording. I'll upload this to our YouTube channel. I can actually just provide you with the link here. And then I will see you at the next one.
Cool. Thank you so much, Ryan, for organizing. Thank you for the opportunity to speak. I really appreciate it.
Yeah, my pleasure. It was great having you.
Yeah.
Awesome. I see some flaps there on the screen, so that's great feedback.
Yeah.
Thanks, everyone. Enjoy the rest of your night.
Cool.
Bye-bye.
Bye, everybody.